Okay, so we're going to continue 2.8 and we'll start off with our exercise. So we want to, given the function 3x plus 5, we want to show that g of x, which is x minus 5 divided by 3, we want to show that f composed with g of x is x, and g composed with f of x is also x. Well, f of g, that's 3g of x plus 5, which is 3 times x minus 5 divided by 3 plus 5. So the 3's cancel. We get x minus 5 plus 5, which is x. So that part works out just fine. Similarly, g composed with f, that's g of f of x, which is f of x minus 5 divided by 3, which is 3x plus 5 minus 5 divided by 3, which is 3x divided by 3, because the 5 and the minus 5 cancel, and that gives us x as well. So this one is not, the algebra is not too bad. What we want to do then is to graph both functions and see that they are reflections of each other across the line y equals x. So for 3x plus 5, so so at 0, we're just going to, at 0 we have the point 5. So 1, 2, 3, 4, and 5. And if x is negative 5/3, so if I have, so negative 1, negative 2, negative 5/3 is somewhere here, then we have the following line. Oops, sorry. Something like this. And on the other hand, if I take x, so let me draw this a little better. So it's kind of a steep line, so it should be something like that. Okay. And now we have the line y equals x, which goes, something like right in between. This is y equals x. And then, so the points swap, right? This point was the point 0, 5. So we're going to get a point 5, 0. So 1, 2, 3, 4, 5. We have 5, 0. We also had the point here. This was negative 5/3, comma 0. And for the other one, remember that g of x here, oops. So our f inverse, which we called g, was x minus 5 divided by 3. And so you would have the point 0, negative 5/3. So negative 1, negative 2. So negative 5/3 is somewhere here. And indeed, you can see that we're going to get something like this. And so you can see that these two lines, the green line and the white line, so green line and the white line, they are reflections of each other, across y equals x. Okay, so Just wanted to see that graphically as well. What we're going to do is we're going to do some inverse functions now for things that get a bit more involved. So we're going to now ask the question, how do we find an inverse function? Till now I've been giving you candidates for the inverse and we checked the property. But we can actually find the inverse directly. So we're going to do an example here. So we'll do two examples. Say f of x is 1 over x plus 1. And we want to find f inverse of x directly. So what we'll do is we'll do that, and then we'll actually show that f of f inverse of x is x, show those two properties, that it actually works. Okay, so how do we do it? Well, we have the equation. Let's look at it in terms of x and y. Y equals 1 over x plus 1. So our method, the method for finding f inverse of x is to swap x and y and then solve for y. Because essentially for f and f inverse, it's an order reversing process, right? So the order reversing process corresponds to swapping x and y. So for example, in this case, when we swap, what do we get? Well, we get x is equal to 1 over y plus 1. And now our goal is to solve for this y. And that, whatever we end up with, will be the inverse of f. Okay, and again, I didn't check that this is 1-to-1. You can graph this function and check that's 1-to-1, but we're just going to assume that it is 1-to-1, and so we can do this. Well, what do we get here? We get, if we multiply x equals 1 over y plus 1, let's multiply both sides by y plus 1. So we get x times y plus 1 is equal to 1. And so we have xy plus x is equal to 1. And so I'm going to bring the x. I want to solve for y, so I have xy is equal to 1 minus x. So y is equal to 1 minus x divided by x. Okay. So what we get then is f inverse of x is actually 1 minus x over x. How do we know that we got the right answer? It's a good question. Well, we need to check, so we have to check. It works, but just to check, just to be safe, we'll check the properties that define what it means to be an inverse function. So what do we need to do here? So here we had f of x was 1 over x plus 1. And our candidate for f inverse is 1 minus x over x. So let's take f and compose it with f inverse and check that property. Well, this is 1 over f inverse of x plus 1, right? Because this is f of f inverse of x. Well, what is that? That's 1 over 1 minus x over x plus 1. So now we need to add in this denominator, we need to add these two rational fractions. So how do we do that? Well, we have a common denominator of x. For this function, we have 1 minus x. For the 1, you can think of multiplying the top and the bottom by x. So we get plus x over here. And notice here that the left function is 1 minus x over x. The right function is x over x, which is equal to 1. So this is equal to 1 divided by, well, the negative x and the positive x cancel. And hence we get 1 over x. If you divide two fractions, this is 1 times x divided by 1, which is x. So indeed, f of f inverse of x is equal to x. Let's go the other way. We also want to show that f inverse of f of x is equal to x. Well, what is this? This is f inverse of f of x, where f inverse was 1 minus x over x. So we're going to replace the x there with f of x. Okay, what do we get here? We have 1 minus f of x. This is 1 over x. This is 1 over x. Well, let's go ahead and do the division here. 1 minus 1 over x times, right, the numerator times the reciprocal of the denominator, or the flip of the denominator. Let's distribute that. What do we get here? We get, this is equal to x over 1 minus x over x. This is x minus 1. Well, so, oops, I'm sorry. I made a mistake. The f of x was not 1 over x. It was 1 over x plus 1. Sorry. So this part here. So this was supposed to be x plus 1. This was supposed to be x plus 1. This was x plus 1. This is x plus 1. Okay, now we're in good shape. Sorry. So it was not 1 over x, it was 1 over x plus 1. So we have 1 minus 1 over x plus 1 times the quantity x plus 1 over 1. So this becomes 1 minus 1 over x plus 1 times x plus 1. And now we distribute this term by term. We distribute this here, we distribute this here. This is x plus 1, when you distribute there, minus x plus 1 divided by x plus 1. Well, this cancels to give us a 1. This is x plus 1 minus 1, and that equals x. Okay, just to reiterate here, the f of x was 1 over x plus 1, right here, divided by, again, 1 over x plus 1. We take this and we multiply by the reciprocal of the denominator, and x plus 1 divided by 1 is just x plus 1. And then we distribute, multiply term by term, and that gives us our desired result. Okay, so I'm going to leave you here with an exercise. So suppose f of x is equal to 2 over 3x minus 1. So your goal is to find f inverse of x, and you're going to swap x and y. You're going to solve for y after the swapping. That's how you're going to do that. And then go ahead and show that f of f inverse of x is x, and show that f inverse of f of x is equal to x as well. Okay, we'll stop here for now, and we will continue next time.